We're going to work with some vocabulary. At the beginning of the chapter, we talked about a monomial. Remember, monomials may be variables. They might be constants, meaning numbers, or the product of either one of those. A binomial, like with a bicycle, means two monomials. It is the sum of two monomials. Like tricycle, is the sum of three monomials. And then we don't get too fancy with our words after that. We have polynomial, the sum of four or more monomials. So bicycle, the sum of two. Tricycle, the sum of three. Polynomials, the sum of four and more monomials. Okay, so let's just do a few examples of each type. For a monomial, it could just be a digit. So I could give you 7. It could be the product of a digit and a variable, 13n. It can include negative numbers and exponents, negative 5n cubed. It could be multiple exponents, 4a squared b c to the 5th. All of those are either constants, variables, or the product of the two. When we get to binomials, remember the sum of two monomials. So I have 3 plus 4y. This is a monomial. Plus 4y is a monomial. 2a plus 3c. Here is one term or monomial. Here is the second. 6x squared plus 12xy cubed. Again, here is one term plus a second term. What are your thoughts about this one? 7x y cubed minus 9x squared yz. Oh, I used the word sum in the definition, but I gave you subtraction. Remember, this could be written as 7xy cubed plus a negative 9x squared yz. But we do not write plus minus signs. We've talked about that in earlier chapters. You do not do plus a negative. But subtraction is really adding a negative. So subtraction works. Okay, trinomial. I think you understand what might happen. X plus y plus z. First term added to a second term, added to a third term. Each of these terms are monomials. X squared plus 5x plus 17. The first term are monomial, second term are monomial, and then a third. They again could have subtraction signs, and that would be okay. Term 1 is a squared. Term 2 minus 2ab. Term 3 negative b squared. They could just be absolutely random. Making it up, it has 3 separate monomials, therefore it is a trinomial. I'm not really going to give you too many examples of polynomials. I think you're understanding. It would have to have 4 or more monomials. So x squared plus xy minus y cubed plus 10. Each of these terms follows the rules of a monomial. I have 4 or more. We could totally get super crazy, do 9x cubed plus 8x squared y minus 4y cubed plus 12x minus 1. It could go on forever. Here's one monomial, 2, 3, 4, and in this case I added a fifth. When you look at these two examples below the table, why isn't this first one a polynomial and why isn't that one a polynomial? Take a minute. How does it look different than any of the ones we wrote in the table? We talked about this in the very first lesson. You may not have exponents or variables in the denominator because that is not multiplication. Here, because my y is to the negative 5th power, I would have 9x cubed over y to the 5th. You may not have variables because that's a quotient, not a product with negative exponents. Okay, pay very close attention to the next part. Degree of a monomial is the sum of the exponents for all variables, just the variables, not the constants. I will then just look, I apologize, at the exponents. I have a 5, a 2, we have that invisible 1. The degree of that monomial would be 8. Now when I look at the next one, the sum of all the exponents of the variables only, so I will not look at that. 7 plus 4 plus 3. 14. Ooh, x has an invisible 1 there, so I would have 2 plus 1 plus 5 plus 3. So I would have 3, 8, 11. It would have a degree of 11. When I compare that to the degree of a polynomial, we just did monomials, now we're on polynomials. The greatest degree of any term, meaning individual monomials in a polynomial. When I look at this one, what kind of polynomial is the first one? I tried to separate them with colors. This is a trinomial. It has 3 monomial terms. So this is a trinomial. Okay. Term number 1 is 2 plus 1 is 3. This part of it has a degree of 3. This one, 2 plus 2 is 4. The center term or monomial has a degree of 4. Invisible 1, 1 plus 9 is 10. The third monomial or term degree is 10. It is always the greatest degree of any term, monomial, in a polynomial. So this would have a degree of 10. 10 is the biggest number. I do not add them together. I look at them as separate ones, select the biggest number. So I'm going to isolate these. The first one, 2 plus 2 is 4. The second is just 7. The third, both x and y, have invisible 1, so it has a degree of 2. Oh, what about the variable at the end? There isn't one. So it could be any variable to the 0 power, because that equals 1, or you just simply say 0. So this polynomial, because it has 4 or more terms, degree of 7, because 7 is the largest number. Now we're going to arrange polynomials. Arrange the terms of the polynomial so that the powers of x. Traditionally, you have to read very carefully. The powers of x are ascending. When I think of ascending, I think of airplanes. When they ascend, they are going up, increasing. All right, so we are going to list them in increasing order, smallest to greatest. When I look, maybe I'll separate my terms again. I am looking at the exponent attached to the x. Oh, there isn't one here, so we can kind of think of that as 16 times x to the 0 power. So that would be the smallest, plus 2x, because that has an invisible 1, minus 14x squared. I don't care about the negative 14. I am just looking at my exponents, plus 14x cubed. Exponents are in ascending order. On the next one, they want me to write in ascending order following the x's. It does not matter what the y's are doing at all. We're only going to look at the x's. Well, this first term doesn't even have x's, so it will go first. Here I have x to the first power. I don't care about the y, so 2xy cubed. At the end, we have minus x squared y squared. Finally, plus 4x cubed. Again, looking at the x's, x to the 0, x to the 1, 2, and 3, ascending order, completely ignoring the y's. So now when we start looking at terms of x only in a descending order, it would mean just the opposite, decreasing. Then we will be going from the largest to the smallest. Think of a plane descending is going to land. 99% of our work moving forward, we will be writing things in descending order. I will not provide gray area. So, descending, this has my biggest exponent, so 6x cubed. There's no sign in front of that, so that means it has to be positive 9x squared minus 3x minus 10. 3, 2, invisible 1, and then there's 0. Again, I'm going to completely ignore the y's. In descending order, I have negative, watch the negative sign, 4x cubed y, took care of that one, plus 7x squared minus 12xy cubed plus 8.